So thank you for joining me to listen my monologue that I have made on our course focusing on the basics of optics, and that this course, of course, we have in the Tampere University. So I will start my series of lectures by just giving a brief general outline of the different chapters that we will be covering during this course. So in the first one week, we will be starting with the descriptions of light. So that'll be the chapter 2 in our booklet. And then we will be hurrying forward to describe wave motion. So the first one, the chapter 2 that we will be discussing, is a very general outline going through the basics of optics and what is electromagnetic radiation. We will introduce briefly, for example, the Maxwell's equations, the concept of a wave equation, and so forth. And then in the chapter 3, we will focus more on the mathematics that arises subsequently from the wave equation. Then after that, in chapter 4, we will focus more on the Maxwell's equations and the subsequent notion of electromagnetic waves that arises, and we will cover the math and the implying physics that arises from this piece of mathematics subsequently. Then in chapter 5, we will focus more on light-matter interactions. So what we mean with that in the curriculum of this course is that we will introduce to you main processes of absorption, scattering of light, spontaneous emission, and of course stimulated emission that provides us, for example, a possibility to realize a laser device. So that's what we will be covering in chapter 5. And after that, we will change our gears slightly, and we will be focusing more on the kind of propagation properties associated with electromagnetic waves. So we will be, for example, trying to understand what happens when a ray of light hits an interface between optically two different materials. For example, that could be the interface between air and a piece of a glass, such as a lens. And we will be seeing what happens on that interface. Part of the light, of course, reflects, part will be transmitting, and we will try to understand quantitatively what happens on those processes. And that, of course, will provide us a prelude to understand, for example, what happens in the final parts on geometrical optics, when we will be more focusing on optical components such as mirrors and lenses. Then in chapter 7, we will be discussing more about superposition principle. Of course, superposition will be introduced already in the chapter 3 regarding wave motion, but here we will be speaking it a little bit more on a general terms, so that we will motivate and prelude the chapters of 8 and 9, where we are then covering interference effects and the basics of diffraction. So there, basically what we will learn laterwards is that it's really the superposition principle and summing of different waves together is that we really start seeing effects such as interference and diffraction. And in here we will be covering in chapter 8 a little bit about interference effects. So for example, we will be covering Fabry-Perot resonances, what's the origin of that kind of resonances. We will be covering a little bit about the physics of thin films and related components and related optics. And then in chapter 9, we will be focusing on diffraction. And these, of course, both of these effects, interference effects and diffraction effects, we can also see in plenty of occasions in nature. But here, for example, diffraction makes me think of diffraction gratings. So that kind of structures we can understand afterwards. We can also understand formation of diffractive colors that arise in many natural locations. For example, in many animals, in bird feathers, for example, we may have diffractive coloration in modern cars, fancy cars, I would say, or cars specific type of people like to use. We may have diffractive colors that make the cars a little bit stranger looking. And in many of the insects, the shells of insects actually are being colored by diffractive colors. And then finally, in the ending of our course, we will be dealing with geometrical optics. So the kind of basics that can be used to already understand many of the optical instrumentation that exists out there and are being used to do many of amazing things. So this is our table of contents and the outline for this course. So now you know and have learned already what we will be discovering in 5 minutes. So I thank you for time, and please join me to follow up the next lectures where we are actually starting to go through the material. And of course, we will be starting this week on the descriptions of light and on the wave motion. So the very first basic notions that we need to understand what is light and how light, in meaning electromagnetic radiation, propagates inside a material. So thank you for listening, and please stay tuned during our course. Thanks and bye-bye.